face you recognize, been there for a lot of our meetings in the last year. So I've also been the person behind the camera for the last several meetings, actually recording our meetings for us and posting to YouTube. I want to thank you for that, as well as say I hate you for that at the same time. So I realized how bad of a speaker I am as part of that, watching myself. So I'll try to speak much slower tonight than I normally do. Please let me know if I talk too rapidly. But it's been nice seeing the videos up there. Actually, I watched the one of the Ross more than once, actually, going through that one, looking through, taking notes down from that one. So as far as the bio, Charles West is a graduate of NC State University, Dr. Grant's Research Lab, the CRIM, Center for Robotics and Intelligent Machines, a really great research group here on campus. Longtime friends with TAR and the Tri-Embed group, and also founded NC State Chapter of SED. Students of Exploration, Development of Space. As part of that, we did a joint balloon launch, a near space balloon launch earlier in the year. Speaking tonight on behalf of NGAT, part of the North Carolina Department of Transportation. The title of the talk is the Quadrotor. What happens? Floor is yours.
To start with, I would invite the head of NGAT, is that how we say it? And to talk about what exactly this thing colors and represents.
Cool.
Talk about quadrotors.
I will do that. So I'm a past IEEE member. I got out of the game when I moved into more of the operational focus on all this stuff. NGAT was started in 2012. The Next Gen Air Transportation Program, looking at airspace modernization as the FAA is transitioning to more aircraft up in the air, smarter aircraft, glass cockpits, all that kind of stuff. I know Tom's a pilot. Anybody else pilots? A couple of pilots. You see where we're going. How all that stuff kind of supports, where things are going to be in the next 15, 20, 25 years, so that we've got that capacity in place. DOT funded the NGAT to start with a grant here at NC State in the Institute for Transportation Research and Education, ITRE. So I'm just over in Research 4. What we're really trying to do is look at how can we support the growth of this ecosystem in the state. So use the engineering talents we've got, use the operational talents, build the industry base so we can grow all this stuff up, give them the workforce they need to take the new technologies, transition them into operational fields, and then kind of grow everything out to make North Carolina, say, next in flight, not just first in flight, or first in modern flight, or however you want to kind of coin that one. It's all good. But that's what we're trying to do. So we're doing that here through NC State, through the NGAT Center, with our primary focus right now being UAS integration, unmanned aircraft systems. UAVs, I just won't call them drones. So one of those things would be, all right, how do we do the technologies on the autonomy development, the robot machine, human collaboration kind of stuff, but also how do we get these things up in the airspace, make sure they're deconflicted with other manned aircraft. So we're getting more aircraft up in the air so we can go do the real estate things, we can go do the aerial photography things, the flying over farms and all that kind of stuff. Given NC State's background and diverse background in College of Ag, our remote sensing GIS guys, and of course all the computer science, ECE, mechanical and aerospace engineering. We've got really almost the whole spectrum here. I had a meeting this morning with Lenore Community College talking to them about how to do some more of the pilot and initial training on that side. So we're trying to build up all of that here in the States so we can say, yes, companies come here, grow here. We've got places where we can fly. We've got 6 locations where we're flying right now with FAA waivers. So the real estate guys that are out buzzing around just shooting aerial photography on the weekends or flying over wedding photography, flying these things now for commercial service, the FAA would say is illegal. We're the only agency, the only government agency in the state authorized to fly by the FAA. We are working on the certificate of authorization. That's the waiver to fly the Phantom. We won't do the Articopter, we'll do the Iris, the other 3D robotic work. So we've got that. We've got 10 aircraft that were approved to fly today at 6 locations, including the NC State Butner Beef Cattle Farm, the Lake Wheeler Farm just south of school here, right off the highway. Up in Moyock, up at the Academy property from Northeast. Hyde County Airport. Anybody been to Hyde County Airport? The least used of our public airports in the state, number 72. Take 64 out, just keep going. When you hit the water, turn south and so much further down, about an hour south of Cape Town. 30,000 acres of farmland, no permanent residents, no nothing, so corn doesn't complain when we're out flying. big open space. That's our primary test site. Tom's going to take a team down. We're going to do a prescribed fire burn in February down in the Green Swamp, down outside of Wilmington. And Vernon James Center in Plymouth is another research site. We're doing some stuff with the soil science guys over in the College of Ag there. And it's all safe. So we're flying those places, but flying inside we're free to do whatever we want to do. So that's where when Charles came up and decided to join in this semester and say whatever I can do to help out, I started throwing a lot of stuff his way. DOT has funded us to do a project to look at bridge inspections, landslides, basically how can UAVs be used as an inspection tool. DOT is not saying, this is one of the things North Carolina is doing that other states are not doing, is how can we use these tools? State agencies aren't saying let's go buy the equipment, staff it with a pilot or 2 pilots, spend all our money in infrastructure kind of stuff, go into the process just to figure out, you know what, the imagery didn't work. They're saying, NC State, you guys have the program, you've got the FAA relationship, you've got the resources like our pilots, like our equipment. Show us what kind of products we can get. So one of those right now, the one we're doing is this inspection tool project with DOT to get out. Let's go fly under bridges. Let's go fly over rock slides, landslides, do the 3D mapping kind of stuff. Say, yes, I can get this kind of resolution. I can see these kinds of things. We can carry these kinds of payloads. Is this useful? Where else does it need to go? How can we lean on industry to go build these things, make them better? Is it repeatable? What are your needs? So that's where we've enlisted Charles and some of the other guys out of EC, and they're really leading this effort. We hired Fred Livingston out of his group, a postdoc that just finished up in the last semester. So he's now really kind of our chief systems engineer for the team. So we're doing all that. We'll start flying. We'll ask the FAA for permission on where to fly for some of those projects early next year. Start flying those in the spring, but for doing that for now, we're going to test some of this kind of stuff. I think that should be there for everything we want to talk about tonight. I'll hang out tonight, happy to answer more questions. And start, if you got anything burning, you're ready to get off the chest. Easy for me.
Thank you.
Yep.
Okay, so raise your hand if you've flown the quadcopter or done on phase 1. Okay. Okay. Are you guys aware of the basics of how a quadcopter works as far as the accelerometer? Okay. So quadcopters are really interesting in that they are inherently unstable. If you fire one up and try and set all of the motors equal and just leave it like that, it will immediately flip over and have lower control, which isn't so good. So what we've been able to do nowadays, since we have all these wonderful electronics that many of you work with on a day-to-day basis, is to stick an accelerometer/gyroscope unit on there that says, wait, I'm rotating. Let's compensate for that until the center of gravity is pointing directly down. Unless you actually want to move, in which case you can tilt that a little bit. But the fact of the matter is, quadcopters are unique in that if you have a normal quadcopter and you stick a weight here, completely changing the center of gravity, it will fly normally because it just automatically compensates for it. So that's the sort of thing that you get out of the box with a quadcopter. What you don't get out of the box is a lot of other things that are necessary for the good condition of bridge inspection. For outdoor, landscape surveys where you're just flying out, you have GPS, which can give you a global view of where you are and allow you to do things like landing. If you're doing something underneath a bridge, you're underneath a whole lot of metal, GPS probably isn't going to work. And so you need to figure out some other way, how are we going to actually steer this thing, crash into something, or run into traffic. So the first thing that our group is looking at is taking one of these things, which is a Quadrotor U3. It's a 32-bit computer, quad-core, 1.7 GHz. Pretty darn fast. It's about 8 to 12 times as strong as a Raspberry Pi in computation power. And we're going to hook it up using USB to one of these guys. It's a low-level, also 32-bit computer, 50 megahertz microcontroller. And this is going to be hooked up to a godly number of ultrasonic sensors so that we can have ranging on all sides. What that should get us is, oh no, I'm about to hit something. And the approximate direction of where you're about to hit something. Now, going forward from that, we need to figure out how to get actual navigation indoors, underneath things, and be able to figure out how to get our sensor where it needs to be, since we're trying to focus bridge inspections, and at the very least we need to be able to go around the bridge. Now, you could just manually pilot it, but we're trying to get toward this being done automatically with just before. You press the button and it goes. Oh yeah, before getting further, just about all of the research stuff associated with this project is on the GitHub page, nc-doc-bridge drone research project. I have notes on pretty much everything that we're doing on there. So if you're interested in a particular aspect of something I talked about, one, you can shoot me an email, or two, come on to actively planning this. Or two, you can go to GitHub and look through, and I have links to lots more resources. So one thing that really caught our attention is that with some of these platforms, people have done a lot of the work for us. I imagine if you guys are interested in capture it. In particular, we had a talk before about ROS. Raise your hand if you were at that talk or remember. Okay, real fast then. ROS is a communications infrastructure developed by Will Garage, which allows you to make modules of software which communicate with each other over either in-process communication on one computer or over the network. So you can just publish stuff and other processes can use it without you having to know all the details behind it. So this is a ROS package. And what it does is something very, very handy for trying to work with this particular quadcopter, which is called an AR drone. It's about $300, primarily a toy. Now, what's cool about this quadcopter is that it has several things besides just accelerometer and rotation gyroscope built into it. One thing, it's got an ultrasound on the bottom, which means it can tell, wait, I'm about to hit this up thing on the bottom, and so you can automatically take off just by sending a command. It will go up about a meter in the air, and then say, okay, I'm this high up and maintain altitude. Whereas if you don't have a sensor like that, you might drift here or down or hit something, basically. The other thing it's got is a camera in the front, a fairly high resolution one at that. A camera in the bottom, and also a Wi-Fi connection so it can stream video. What this library here does, our drone autonomy, is it takes all of that stuff, streams over the network connection, and makes it available as a ROS script. So you can fire it up in all of your other ROS programs and immediately use it. Which means that you can get nice building blocks, such as this other package we've been working on, which is called Ardrone. And it allows us to do stuff like, we'll go to the left-hand view first. So the drone is hovering. I am not actively controlling it. It's flying on its own. So it's supposed to go up, hover, fly up, and then do a rectangle. So it went out the camera for a second, it should be back down in a moment. There we go. So it's flying this little rectangle. You can see there's a bit of drift, but overall it gets to the place and it hovers one point at a time. Now, I mentioned it was able to hover in one spot. This is me going up to it and shoving it out of its position that's supposed to be in, and is using the information from that camera to figure out its position and adjust right back to that spot even after I've observed it. Now, the cool thing about this is a ROS library. I did not have to write any code. I just had to configure it, get it up and running, and then do some stuff with camera television, which I'll admit actually
Who's seen some of the videos from like the UPenn lab where they're flying through hula hoops and through windows and all that kind of stuff, right? You want to explain kind of the difference between those two?
Yeah, there's a very big difference. In all of those really fancy quadcopter videos you've seen where they like catch a stick as it flies through the air, what they don't show you is that there's a ring of like 12 cameras watching that quadcopter, telling exactly where it is in three-dimensional space. We're not going to have that when we're out inspecting bridges. So what we're trying to figure out, and it's a very active research field in robotics in general, but specifically with quadcopters right now, is how can I tell my position using a camera or a 3D sensor and be able to figure out without having 12 cameras and an entire room devoted to telling you where I am. So, let's see what that looks like from the Arduino perspective. So this is actually a live feed of my laptop. I took this shot this afternoon. Here's the coordinates telling it where it's supposed to go. This is what the quadcopter sees right there. It's marking points of interest. So I restarted it, now it's about to take off. There we go. So it's marking points of interest and then calibrating to get an idea of which ones would be good for these guys. So now it's trying to keep track of where those points are, and it's using something called the 8-point algorithm to try and estimate where it is in 3D space. So you can see it has a look, track control is good, goes through there, starts doing the maneuvering, and then if we watch long enough, we'll see them talking about them up again.
What do colors mean?
Not much, I don't believe. I think they just want variation. I believe red. Yeah, I believe red are the ones that actually need to go off. So one of the wonderful and interesting things with open source development is how layers or libraries that are built on each other as layers. So I mentioned the Arduino Autonomy library. What that was built on what this particular thing was built on was a combination of the Arduino Autonomy library, which was giving it the video feed and accelerometer sensing and control of this guy, with something called the PTAM library. And what the PTAM library was originally meant for was doing sort of augmented reality. Have you guys heard of that? Okay, cool. So what it was meant to do is, I take my phone out, I stare at this table, and then it figures out where this phone is relative to the table, so I can stick in random 3D generated objects in my feed from the camera, and it actually looks like it's there. So it wasn't explicitly designed for quadcopters, but what they're able to do is use that same position sensing to figure out where the quadcopter is in 3D space and be able to correct those variables, basically to get to where you want to be. The big problem with monocular algorithms like this, which use the structure for motion, where you move and tells you where you are relative to that motion, is the fact that they have no sense of scale. You get around that with the AR drone here, using the ultrasound sensor on the bottom to say, okay, the scene is actually this big. But the problem is, you don't always have good data, for instance, in the field. In particular, this one, if you fly forward and go over from this table to off this table, all of a sudden, wait! The floor got so much further down, I must have jumped up in the air, or the scene flew way out. So what can happen with this PTAM library, and specifically this drone that I've been working with, is occasionally it gets a wrong scale reading. It thinks that everything is way smaller than it actually is. And then you tell it to go up a meter in the air, and it goes up 10. Which is a bit of a problem in that it hits the roof, and you have to keep your hand on the land button because it goes out of control. Now, there's other things you can do with these monocular SLAM techniques. For instance, we're trying to do bridge inspections, right? So we want to have something that the person doing the bridge inspection, or the person sitting in their office trying to figure out whether or not this bridge needs repair or not, can actually use. So ideally what we like is a high quality model. And that's where this other library that we're trying to work with comes in. It's called LSD SLAM, and it's doing the same sensing of where the camera is, but it's also doing a dense 3D reconstruction of the scene that's looking over. So you guys may have seen Connect videos where they do this same sort of making a 3D model as it moves. Well, if we use this library working and it works anywhere near as well as their demo does, then we should be able to do 3D reconstruction of the actual bridge, and then have the guy in his office sit back and say, okay, this bridge is okay or not, because of they can look at the high quality pictures on the model. So you can see they're able to move, and as they move around, it's a very nice model. This is another open source library. It's out there as a ROS node. They're not being particularly helpful as far as people actually getting up and running with it, and the instructions are about a page long, and they have beyond that. But if you're interested in this sort of thing, the technology is moving in this direction. The title of this talk was, I Have a Drone, What Now? The reason is, there's a few things that are easy with drones. Getting it to go forward at a set speed, that's an easy thing. What's active research right now is getting it so that a fundamental part of the drone is, I'm in this space. If I want to move 5 feet forward, rather than having a set velocity, I can say, set distance forward, and I'll just do it. There's been some development in the last few months in that area, but I think that's something that we're going to start seeing as a set feature of the drones onboard computers that can do this sort of state estimation. So,
how about dead reckoning? Is that?
I mean, dead reckoning traditionally, I believe, is generally based on geometry, where I've moved this far forward with my wheel, therefore this is where I
got
am.
somehow measure
Yeah. So what you need is absolute position, so that when you come back to the same spot, you can say, okay, I was here. Because if you just use the accelerometer, drift over time, there's no difference. Okay. So this is some of the 3D reconstruction I was talking about. Like I said, LSD SLAM is a really interesting library for that. However, it's not the only one that's out there. Apologies if I'm drifting this in terms of topic. Basically, we need this 3D reconstruction to be able to take the grid and model of it and do this with that. So we've been going through a whole bunch of different 3D reconstruction algorithms, focusing in on the source from motion ones because it's really easy to get a high definition camera. But if you look at like the Kinect style sensors, most of them don't work outside because they project infrared and the sun completely won't, which maybe would work underneath a bridge, but in general we've been having trouble finding the sensors without electricity at all. So there's several different options that you can look at if you yourself are trying to do some 3D reconstruction stuff. Who here has ever heard of Microsoft's PhotoSynth? PhotoSynth. Okay. PhotoSynth is an interesting application. Unfortunately, I can't show off too much because I'm running Linux and they don't like Linux. But what it does is the same sort of camera positioning estimation stuff, where it constructs a very sparse 3D model of the scene. But what it does is it estimates where the camera that took a particular picture was, and what you can do is you can move through the scene going from picture to picture. So I'm at this part of the beam, I can move over and do this next part. There's actually some tutorials online if you're interested where you can go and retrieve the point cloud from PhotoSynth and then actually do it in 3D. So I found that interesting. The problem with PhotoSynth in particular is you can only do up to somewhere like 900 photos before it freaks out and has like computers so hot and problems like the time to compute. So there's other software out there called Visual SFM, and if I run this video, you can see it actually estimates the camera pose in the same way. You figure out which points to correspond, and so this is an open source library. You can't really use it for commercial applications because it's ETL, but you can just, for Windows, it works off the shelf. You can just give it 100 or 300 images moving around something, and it'll do any sort of okay 3D reconstruction of it. So the cool thing with it is it works off the shelf.
that one's called what?
That is called Visual SFM. And like I said, in GitHub there are extensive notes on all of this stuff. If you go to the folder entitled 3D Reconstruction, there's a link to this and other tutorials. So, we have 3D reconstruction, we have a little bit of orientation as far as where we are in 3D space. So the question is, where as a whole is this field going? Like I said before, I think we're going to start seeing a lot more features integrated into the quadrotor itself. Right now, people are selling off the shelf this. Has a few things added onto it. This has GPS. That's pretty much it. This has a very nice cover and used to have a camera until it crashed at the state fair. But built in, all it really has is GPS. You can have it fly around and take pictures of an outdoor scene, but it will weakly crash into something. And with rotors and motors this big, it can actually really hurt somebody if it does. In fact, I believe Frederick, who may or may not be appearing over this evening, who is a member of our group, actually has a scar, I believe, from one of these rotors. So it's interesting, they sell little tiny $20 quadcopters, which you can fly around and they're good fun. You can smack it into your hand and it's not a big deal, you already notice. This one, it kind of hurts if it hits you, but it's not that bad, it's not really going to cut skin that much. Like I said, these ones will really hurt. So there's sort of a sliding scale of harmless versus not so harmless. These ones you really need to make sure it doesn't crash into something. And I believe in a few months we're going to be getting a quadcopter that's worth something like 20 grand.
What's north of that? It's 60.
60. It's a hexagon. We really, really can't crash that one. So, like I said, there's some new quadcopters coming out. One that came out last month at a trade show, I believe, had about 6 ultrasonic sensors built into it. It looks like gimbal cameras are becoming very common. This one has a gimbal camera built in, and the other ones are having these interesting sort of head-looking pods sticking out there that can do very sophisticated swiveling and stabilization. So, in the long run, we have a lot of interesting things that we can add to these. The question that we're trying to answer is, what good are these quadcopters? What could they be used for? So I believe you've talked before about using them for agricultural uses, where you do precision agriculture. Every day you get a new flight which takes a look at your crops and can tell exactly what's going on with them. You use stuff like computer vision to find blighted areas. We're also looking at bridge inspection. Basically, anytime you need a camera in a difficult to get place, one of these quadcopters might be a good application. In the longer run, people are talking about doing automated deliveries with quadcopters. From a technical standpoint, there is really not a strong reason you can't besides safety. Some of these quadcopters can easily go 50 miles per hour with a small payload. In general, GPS is not accurate enough that you could actually land right where you need to drop something off. But the fact of the matter is, if you have a marker there of some sort, you could easily use computer vision to walk onto that marker and come down to a very precise thing. So the big hurdle is, one, once you get to that size, they can start hurting people, and two, the FAA has a very conservative, I would say, approach toward legal matters for these drones. So it's likely going to be a significant period of time before you see these drones deployed. Now, what's interesting is we're starting to see them deployed for some applications, like movies. I think as time goes on and people see them used in civilian applications, it will become less of the, oh no, there's a drone coming, run, it's got a missile, from all these military uses, and more, oh, someone's doing a photo shoot. And I think as that process goes on, there's going to be more applications for drones. So let's see, I can either talk a little bit more about the specifics of the architecture we're using for our implementation of the drone, or I can talk a little bit about the networking library that I'm working on, which will hopefully make it a lot easier to do fleets of all sorts of different robots. Or I could end up. Raise of hand, let's see. Specifics of architecture? Okay, 2 hands. Networking library? Okay, 6 hands, and in the top.
Fourth option, questions?
Yes. I guess since we had 6 people for the networking library, I'll talk briefly about that and we'll talk about it. Okay. So a library that I'm working on is called Society. We gave a talk, was it one talk ago or 2 talks ago? On ROS?
Last
Talk, yes. Last talk we talked about ROS. ROS is a really interesting library that makes it easy. Originally what it was built for is, I have one robot that's doing a million different things. How do I get all those programs to talk to each other well? And it has very nice support for publishing messages, subscribing to different messages, and doing request reply, which makes it really easy to decouple one program from another so that if one closes down, everything doesn't work down. Now, it has some support for doing things over the network, but it was never really designed for that. Like, you can have, say, 4 or 5 machines and it work. There's a few problems. One is it has a dedicated DNS program, which lets each of these ROS processes find one another. The problem is, if that DNS process goes down, none of your programs on any of your machines can form new connections. So that's a problem. Another problem is it's not really meant to be encrypted or used for security stuff. All of your processes on all of your machines have equal rights, and none of the traffic inherently is encrypted, which means if someone malicious gets anything on any of your machines, your entire network is at their mercy. So to address some of these concerns, I've been working on a library called Society of Machines. It, as it says, is a robust, tag-level, secure, pub-sub request reply communication with permissions. That's what it offers. In short, the idea is, I have this quadcopter. It is part of my fleet of 1,000 quadcopters, and I want it to be able to connect to the internet anywhere, anyhow, and be able to talk to me securely to all of the other quadcopters and publish everything and ask for anything that it can, given its current permission set. Which means if someone splits this guy open and does robot brain surgery on it, all they can access is, oh, I'm near a heliport. Could you please open up? And it should transparently be able to talk with the rest of my robots, whether it's on my coffee shop network or my home network or any other machine, rather than just my one secure VPNs which I set up. So the other thing that it offers is tag-based search. So the idea is I have my devices for my robotic fleet, since we're actually getting toward robotic services right now. Any of my devices with anywhere with internet connection should be able to talk, and I want to be able to decouple my processes so that I can have services that some machines offer and other things that sort of aggregate and take advantage. Like, for instance, if I had a quadcopter robot that was working with Society, I might want it to be able to say, okay, quadcopter robot might not be the best example for a beginning thing. If I had a mower robot, and my mower robot can mow a yard in, let's say, 20 minutes, it doesn't really make sense for me just to have my mower robot sit there and mow my yard day after day after day, 20 minutes every day. When it could, in fact, be going around to my neighbor's yards and mowing their lawns too. Maybe I could charge for it, maybe I could just do it as a public service. So one thing that this network allows you to do is do tag-based searching and also be part of the open networks. So I can have it so that my mowerbot connects to my network and says, hey, I'm mowerbot, is there anything I can mow? And automatically my other processes can say, hey, a mowerbot joined our network. We know that there's a yard that needs to be mowed, so let's give mowerbot an order to go mow the network. And like I said, the mowerbot can just move from one person's network to another, and it's immediately, hey, I'm mowerbot. And then since there's tag-based searching, it can immediately say, oh, there's a mowerbot, let's do something with it. So this, once I'm done with it, it works currently on one machine. I need to get some network stuff hammered out in the next few months as from the master phases. But once it's done, you should be able to have all of your devices that have internet capability to be able to talk to one another anywhere you are on any network. And be able to do stuff like have a program that just says, hey, what devices are on this network? Oh, that sounds great. I will get my phone connected to my quadcopter, connected to my mowerbot, and maybe I can make something cool happen with that. So I guess with that, I will break the questions. What are you guys thinking?
We've got a now robot that I'm going to test him on with that to make sure that works here. But I want the quads and the now to be collaborating. So just to keep Charlie up your hurdle.
What kind of RF are you using?
For communication with which one? This one, or this
Well,
one?
for your network, what you just said.
It runs over top the network. So the basic idea is I have an internet connection. How can I reach out to other devices which are on completely separate networks, even behind a network address cancellation box?
Okay.
So how it works is you have the library running on your one machine, which has its network permissions. Each of your processes on one machine talks to a singleton node where they publish their stuff, and the singleton node takes care of the details of being over the network. That singleton node participates in a cord network. You heard of the cord? Cool. It participates in a cord network, which is a peer-to-peer network with all the other things that have server permissions, which you trust to a certain level. And so whenever it hops into the network, what I can do is say, okay, I'm part of this cord network. Who has whatever particular tag thing that I'm looking for? We'll retrieve the list from them and then connect them using zero and two to the network. It's pretty handy for purposes. And what you can also do is have a global cord network, which one or two members of each network participate in. So if you have the global cord network, you connect to the internet, and even if you don't know where any of the other members of your particular network are, you can ping the global cord network and say, hey, could I find a representative of Charles West's home device network? And it'll go through the network and say, oh, you're a member of the home device network, and then the device introduces itself to them and gets a list of all the other addresses that it's going to talk to.
Have you tested that on top of MANET, layer 2 RF technology using in drones?
Out of the box, we're just using off-the-shelf controllers for these.
Okay.
This one does a Wi-Fi connection, so you can connect with it just like any other device. For society machines as a whole, it's meant to run the public TCP IP. It's doing UDP communication for the peer-to-peer network stuff.
So you're looking at trying to use these autonomously to, say, check out a bridge, or are you looking at them trying to remotely pilot?
I mean, it's a research project, so it comes down to how much of this you can actually get going. But what we're hoping for eventually is we deploy this thing, we say, okay, your mission is to scout out the bridge at these GPS coordinates. You press a button, it takes off, scans the bridge without going into traffic, and then returns, and you get a nice 3D model from the video. Again, we may not be able to get all of that working depending on how some of these other things work out. At the very least, we'd like to be able to have it go up and have it scan. And it could be that the camera isn't the best thing to do the scanning. Maybe at some point someone will release a point cloud scanner that actually works outside. So it's out for us too.
And so part of your project here is to find kind of a minimum drone set or sensor set that you need to be able to do some of these working.
Yeah. The interesting thing with a project like this is there's stuff that's possible but really, really, really hard. And in general, if you're doing a project like this that has so many different moving parts that all need to mesh together, you want to shy away from those things that are theoretically possible but require a research team of, let's say, 10 for years, which we don't really have. So what we're trying to figure out is the best way to use what is off the shelf and what is available to do useful things that really mesh together.
But also shape what's off the shelf in the future.
Mm-hmm. Yeah, we aren't the originators of, say, the our drone research that does this, but we can come up with applications for it. We aren't the originators of the LSD SLAM algorithm. That was a like 15-person research team. But at the same time, we can take that library and make it so that anyone off the shelf can apply it to the camera feed.
That's why this is a research project inside the DOT. It's not a, right, you need this imagery captured, so you just come out and just take pictures. If that was the case, then yes, you do it all RC. The guy would just fly up there to take pictures and come back and say, all right, here's what you can see. They were wondering more of how much autonomy is needed. Can it be done RC? Can it be done autonomously. Where's that sweet spot with what are the cameras, what are the resolutions? So our job is to kind of scope all of that and say, all right, here's what we like.
Do you have any information on payload? Obviously, like you mentioned, like doing this inspection, right?
Yeah.
You may actually have bad weather, you may have wind, so you have any kind of like involved characteristics in when you're going to be able to use it, day and night.
Yes, in fact, some of our 3D sensors are actually much better at night, but in general, I would not advise flying them in
Sure.
Yes, by the end of the project, we will have information like that. It may, however, vary from quadcopter to quadcopter, depending on what situations they have on board.
So you're looking also at power. Are you also looking at BRS system or parachute system for safety? Some of them are going to be as a payload, right?
Mm-hmm. Yeah, that isn't our primary focus, but there are several commercial solutions out there that could right.
Okay.
One problem with the parachute is better make sure the rotors are off, or else that things could get snagged.
On the bridges that you're inspecting, state highway bridges, interstate highway bridge, what kind of bridge?
Currently we're going to be assigned testing areas. In the meantime, we're talking with inspectors as far as what stuff we need to be looking for. It looks like with a lot of the bridge inspections, seldom is it like obvious gaping holes in the bridge. Instead, you'll get little spots of rust that you need to look at and figure out what's going on. Because maybe the steel inside is corroded.
So are you looking at the undercarriage of the bridge or the top part?
Mostly in the bridge. Because the top part you can get out of the truck. But some of these bridges are in water or really hard to reach spots. The big challenge there is our 3D models we know are only going to be so accurate. And it seems like they need really tiny details to be able to do the job. So what we're probably going to end up doing is aggressively smoothing along our 3D model and then trying to slap on the highest resolution textures that we possibly can so that they can zoom in and really fine detail on that bridge.
You define tiny, millimeter, centimeter.
Okay.
How about centimeter?
Have you thought, I got two questions. Have you thought about using a sensor that can detect density? Because inspecting a bridge and knowing what, so if your camera or something, or your sensor in general, is aiming at some portion of the bridge, and then you move 6 inches to the left or right, and all of a sudden the density changes, that could be indicative of something going on also. Like water being inside, the density would go up, right?
But what non-contact sensor would you use that?
I don't know, I'm just thinking, this is just an idea, I don't really know what the sensor would be.
Yeah, it'd be interesting, but I can't think of anything on hand besides radar, so that would seem much more effective than power content.
The other question was, what language are you writing? Your society?
C++.
Those, your question about sensors, those are the projects we're really looking for. And we've got our places we can fly, we've got our aircraft we can fly with those approvals from the FAA. I get people coming to me now saying, hey, what do I need to do to get in the drone business? I'm saying, create sensors, create new capability. That's what we need. We don't need more airplanes, we don't need more quadcopters. That market, I would always say, is already flooded. Create capability, create industries, create markets. So those kinds of ideas, let's push there. Give these guys chances to go make new product.
So on that same kind of thought, have you been also looking at existing FLIR, thermal imaging, LIDAR, microsense, for example?
We've looked at LiDAR. The problem with LiDAR is that it's expensive and pretty heavy for one of these platforms. Again, we're a research project, so we have to find a project. I'm actually reached out about 3 or 4, no, it was one day of last week, to a guy that's been mounting LiDAR on, I think it was an octocopter, on located on Pulau, and he's offered us LiDAR sensors. But for purposes of inspection, these really are just platforms that are not sensors on. Yeah. So as those sensors evolve, which is really being pushed by as those sensors evolve, you will see a lot more applications for these things for inspection. The sensors are really being pushed forward by cell phone technology and tablet technology. There's a big push to try and get it so that your phone will have the 3D interface for it. You're seeing projects like Google Project Tango. Intel just released a Intel FieldSense, which has about this much range, but sensors like 8 big. I kind of wanted to use that for this project because there's rumored to work on stereo, which might work outside. But the problem is it requires USB 3, which our little microcomputers don't have, and also it's currently Windows only. Also doesn't work so great with our little microcomputers.
With a little bit of work, you can actually carry rig a tractor for being able to fit a light field camera underneath the thing. The company that makes it is Lightro.
You got one.
You do?
Yep.
You take it apart, yeah.
Right.
You have to take it apart, as in its Wrigley box, it's not going to fit in anything into it. But the sensor itself is only probably 130 grams or so, and the rest is just figure out how to be able to reverse engineer the software to be able to control it. And it makes a great aerial camera.
Yeah, we already had that too.
Have you heard about the Red Eye project from Microsense? You want to go take a look at it. It's a spectral camera. They use that for agriculture. It's pretty interesting. The payload is very small. And it's actually made for drones. Those guys are in Oregon.
There's been a lot of really interesting sensors, like I said, at least in part, that tablets and cell phones.
Yeah.
You're starting to see stuff that is really interesting in this work. And
on the Microsense,
yep.
Look at the website Microsense, and they got the name of the camera is Red Eye.
And you guys have heard of the Raspberry Pi, right?
Yep.
That came out, what was it, 2 years ago? Huh? 2 years. Since that was something about Yabig that was on it. Flat out normal Linux, you didn't have to modify anything to do it. Since then, there's been an explosion into little microcomputers like this one, and it seems like every year we're getting huge increases in performance, which is again driven by these development of cell phones and processors. But the nice thing is, you can fit what is more powerful than, let's say, 3 or 4 years ago's laptop, right here, and it has hardly any weight. And if you compare the power draw of these motors to the amount of energy you want these computers to get, nothing.
So speaking of energy and power, what powers something like that? Is the battery on there now, or I take it it isn't?
Let's see. This one, I don't believe the battery's on board. This one has this battery, which gives it about 20 minutes of flight, I think.
20 minutes?
Something.
20
I think
minutes?
it's the extended battery, so yeah, it's 15 because of the battery. And then if I grab the container over here, these are the batteries for the Phantom. And I think it's something like 30 minutes of flight for that.
Yeah, depending on what you got.
Yeah.
That's without a payload.
Well, the Phantom's payload is its camera, but it doesn't expect you to have a payload. This one is sort of a kit, so you can have that payload.
What's the cost for motors?
Ridiculous. I don't know offhand, but it's a lot.
Many amps.
How long would it take? I mean, I don't know if you have that type of information. How long would it take for you to get the requisite number of pictures off of a, like a normal freeway bridge or something like that?
I mean, requisite number of pictures depends on the book that you're using, and also what exactly you're trying to do. If you're looking for potholes, it requires a heck of a lot of stuff to do that big. So, I mean, the answer for now is we're going to have some high-res cameras and we're going to have some video cameras and see which
It seems like a lot of what I hear is sensors. Your sensor thing is from the drone, but are you looking at using the drone to deliver sensors and place them on
structure and we'll come back?
Yes. One of my primary research interests is how can we take mobile robots and have them deliver actual robotic services, where I'm within this area, which happens to have the robotic delivery service, like a pedestrian sidebar robot that delivers stuff. So I personally am very interested in the idea of having multiple robots do stuff like deploy sensors, or potentially even in the long run deliver other robots. So let's say I have something in Windows. It'd be really cool if I could have a quadcopter or similar platform go stick it on the window and it does its job. Quadcopter sticks away from the window the rest of the time.
So are you following what's going on with that, swarming, activities, like some of them,
Yeah.
DARPA is working on that, obviously.
The problem with a lot of the swarming activities is they're just looking at, oh, we have this cool swarm algorithm which can do such and such. Great. What I'm looking for is a networking and robotic architecture that is like object-oriented programming, for instance, where these are my base components. Now what am I going to make with it? Rather than having to reinvent the wheel every time.
Well, I think that my question to you on the cons also is like when you deploy sometime you don't have access to infrastructure. Your LTE is not going to be there, your Wi-Fi is not going to be there. That's why I think it's kind of interesting to think about, your underlying, your networking capabilities. And one of the things that you mentioned here is that, when you do MANA, you have the possibility of doing web crawling, so you can actually push the services if you want to go and deploy much further where there is no infrastructure.
Potentially. It also depends on who you're trying to talk to. Like society machines will work just fine without internet if all you're just talking to is your camera.
Yeah.
The devices right there on the machine, because you can use it for the process the same way. But the fact of the matter is, cell phones are getting pretty darn ubiquitous and starting to offer creative robots. So when we see the next generation of cell phones pop out, it's quite likely you'll be able to start doing stuff like having the robots for the video you need to, which, if you have good internet connectivity with society machines, also opens up the possibility of, oh, my robot got in trouble, let it go stream its video to the call center, and the operator will deal with that one special situation, and then they'll go on with other business automatically.
So right now for your bridge project, are you looking at streaming data, or are you looking at basically flying the mission, harvesting?
Because you could have wireless connectivity, but if your truck is on top of the bridge and you're flying underneath the middle bridge, I wouldn't bet on it.
Yeah. Real-time data is not usually necessary. So, back to the current that the motor draws, if you're going to send these on a mission, and that mission isn't too far from where you are, otherwise you've got an awful lot of time for that thing to have to fly around.
Well, the other thing is these things can fly really fast if they want to. So if you have a large area where you don't have to worry about them, you can get in position pretty darn quick. But yeah, time is a factor. You need to make sure that your duration of the mission is not less. Or at least have emergency behavior where it detects, oh, I've only got 5 minutes left, I better head back to base.
Regardless of what.
Regardless of what everybody else tells me.
Yeah, but if it can pay attention to where it stopped, and presume that's pretty easily.
One of the other things this group's interested in is, say, 15 to 20 acre small area surveys. Right? Just being able to see what's going on, whether it's a construction site, a potential development site, what's there. And the resolution on that doesn't necessarily need to be very high, because we just need to have that kind of quality to move the dealer up before the points are going to be. And so being able to calibrate the imagery to GIS data is a big deal. So flying these guys low and slow and getting that kind of resolution is a big deal. It beats a GoPro location.
In terms of long-term goals, like I said, side machines are more, as I think they will enable robotic services. You can control your devices without having to assume whether they're third parties and corporations. It would also be really interesting is if we can use algorithms like this and combine it with an online database so that my robot can produce its model of this particular scene, and then the next time a robot's in that area, it loads my model and it can tell where it is, and then it can produce more data to that particular scene. Because with the cheapness of robots and what I think would be quite interesting in robot services that we would offer. You could have everything mapped out and be able to load anytime you have internet connection, something now like the robot knows exactly where it is. You know? And I think that would be an interesting part of it. So, if no one else has any questions, I suppose I'll draw this back to the floor. Thank you.
Before you sit down, you're also going to be putting together our next one as well. Can you describe that to us a little bit?
Bring a road.
Camera's still on.